We're constantly told that our genes are basically code and that AI works with words. But what if those are just convenient fictions? In this explainer, we're going to dive into the surprising physics that actually connects genetics and artificial intelligence. And we're going to challenge the very metaphors we use to understand them. This quote from our source material, man, it just gets right to the heart of the issue, doesn't it? We all know the idea that genes are code or AI tokens are words. They're simple, they're comforting, but what if they're fundamentally wrong? What if they're actually hiding a much deeper, much more profound physical reality? So yeah, that's the core question we're tackling today. We're going to strip away those easy labels and actually look at the raw physics of what's going on inside a cell and inside a large language model. And believe me, the answer connects biology and information theory in a way you probably don't expect. Okay, so first stop on our journey, let's deconstruct these comforting fictions we tell ourselves. This is where we start to see the fundamental mistake we're all making, mistaking our human-made labels for the actual underlying physics of the system. I mean, on the surface, these comparisons make total sense, right? A gene leads to a protein. An instruction leads to an action. A token is part of a sentence. A word is part of a sentence. But this is exactly where the metaphor becomes so seductive and so wrong. Both of these ideas assume that meaning is some static thing, just stored inside the gene or the token waiting to be read. But the reality, according to our source, is so much more dynamic. A gene or a token isn't a static instruction. It's a potential state. Think of it as a latent possibility that means absolutely nothing until a recognition apparatus, something else in the system, physically interacts with it. They aren't systems of symbols to be read. They're systems of physical constraints on what can happen next. And that idea, well, that brings us right to the biggest illusion of all, this whole concept of stored meaning. So let's really dig into where we get this so incredibly wrong, because it has massive implications for how we understand both life and intelligence. This is the million-dollar question, isn't it? If a gene for blue eyes doesn't actually store the concept of the color blue, and a token for the word king doesn't store the idea of royalty, then what on earth is actually going on? And here it is. This is the core insight. They don't store outcomes, they store constraints on probability. It's kind of like this. They don't hand you a specific destination on a map. They just close off a bunch of wrong roads, making certain paths much more likely. They bias the distribution of what's probably going to happen next. Okay, to really get this, we have to talk about something called Shannon information. Now, the absolutely crucial thing to understand about Claude Shannon's framework is that it has nothing to do with meaning. Zero. It is completely agnostic to semantics. It's just a pure mathematical way to measure how much uncertainty has been reduced. A message has high information content if it dramatically narrows down the field of possibilities. This just lays it out so perfectly. See, meaning isn't in the message itself. It's external, something applied by the receiver. A gene sequence doesn't know what a protein is. It just reduces the massive uncertainty about what kinds of proteins a cell might produce. And a token in an AI model? It just reduces the uncertainty about what word is statistically likely to come next. In both cases, they're just playing the odds. So if meaning isn't stored, then where the heck does it come from? Well, the answer is the process of recognition. This is where all the action happens. Meaning isn't some static property. It's a dynamic physical process. Let's take a look at how this actually works. Just look at the journey a gene has to take here. It's not simply read like a line of code, not at all. A whole cascade of physical events has to happen. The DNA has to be physically accessible, then transcription factors have to physically bind to it, the cell supplies energy, a ribosome interprets the result. You see, at every single step, uncertainty is being reduced. It's a physical performance, not a simple data lookup. And now look at a token in an AI model. It's the exact same logic. A token by itself is just a number. It's meaningless. But once it enters a sequence, attention mechanisms weigh it, the context modulates it, and all the layers transform it until, finally, a probability distribution is updated. Again, it's a performance, a physical calculation based on context. The parallels are they're stunning. So how do we tie these two parallel processes together? Well, our source suggests a powerful, unifying concept that really provides the missing link. And it comes from a very, very surprising place: quantum mechanics. Now, I know what you might be thinking. Quantum mechanics? Is this about to get all mystical and weird? The answer is a hard no. This is not about spooky action at a distance or consciousness. It's a purely structural comparison, an analogy in the underlying logic that turns out to be incredibly revealing. Okay, check out this table. In quantum mechanics, a system exists in a superposition, a fuzzy cloud of potential states, until you measure it. That measurement is the operator that forces it to collapse into one single outcome. Now, look at the right column. A gene or a token embedding is a latent state, pure potential. The recognition machinery, the cell's enzymes or the AI's attention mechanism, that's the measurement operator. And the outcome? Meaning, action, a collapse of infinite possibility into one concrete reality. All right, let's bring all these threads together now. This is the grand synthesis, the core takeaway of this entire explainer. And the most crucial point is that recognition isn't a mental act. It's not done by a mind or a consciousness. It's done by a physical process. RNA polymerase physically recognizes a promoter sequence. An AI's attention head physically recognizes the alignment of mathematical vectors. These are physical acts that require energy and reduce uncertainty. So, what does this all mean? It means that meaning isn't something that's inside a gene or a token. It's something that emerges from the interaction between that gene or token and the system that recognizes it. It's born from the physical act of recognition itself. And this is the ultimate punchline. We have to shift our entire framework. Meaning isn't a noun, it's a verb. It's not a thing you can look up in a library. It is something that is actively, physically performed, moment by moment, by the machinery of life and computation. This new perspective has some really profound implications, and it forces us to confront one of humanity's oldest illusions, the illusion of a designer. So why do complex biological structures or sophisticated AI outputs look like they were intelligently designed? Well, it's because optimization without any intent whatsoever looks like intent. Structures that survive and replicate are simply the ones that got better at reducing uncertainty in their environment. We're the ones who look back and tell a story about purpose, but that purpose is just a story we tell in retrospect. Let's just sit with that for a second. That is a stunning reframing. These incredibly complex systems aren't the product of some brilliant designer. They are the inevitable result of physics. They're what happens when entropy, the universe's tendency towards disorder, gets constrained and starts to fold back on itself, creating structures that recognize and perpetuate themselves. And that leaves us with a final provocative thought. If we have been fundamentally misunderstanding something as basic as meaning in our two most powerful systems, life and AI, what other comforting fictions are we telling ourselves? What else are we getting wrong?